Today we are going to build stepper to be the clock bit of the control unit. It is the sequence for the control unit to give a signal at different places to accomplish different tasks. The first D flip-flop connects to negative trigger clock, and for the second one we will connect to positive trigger clock. And for the rest of the odd number of flip-flops such as third, fifth where they all connected to negative trigger clock can be ignored in this circuit, but for the purpose of showing it's working hence they are placing in this circuit. For S1, S2, S3 till S7 each step exists on every one clock beat cycle only. Here this is the instruction cycle of the control unit, and you can design as many of steps you want for the stepper, but it will slow down the speed of the computer as it needs more time to step through all of the steps. After this demo, you can see how this stepper works in first few clock cycles. Here I have connected the S4 to enable the R1 and load the temp register. So when the stepper reaches step 4, it will let the input go through and load into temp register to update the output. Now in step 4, the temp register output is connected to the input B of the ALU. For step 5 the input R0 is connected to the input A of the ALU and, in the same time the ACC accumulator load the result of the ALU and show on the output. For step 6, the stepper enables the ACC output and load into the R0 input. Hence it will keep adding up the previous answer. For an example, input A of ALU is 0 and input B of ALU is 1, hence for the first cycle ACC output is 1, and this output will be put back to the R0 in step 6, and for the second cycle the input A will be loaded by R0 and become 1, and the ACC output will be showing 2. Here I will repeat its logic so that you can familiar with the stepper's function. For step 4, R1 input loaded into temp register and feed into the input B of the ALU. For step 5, it enable the output R0 to be loaded into input A of the ALU. And for the step 6, it will allow the ACC output to be loaded back into R0 to update the R0. You can also use RAM to store the result of the ACC. Here is the end of the video. For the next video, I will show you the process of fetch, decode and execute, which is how the CPU mainly does this kind of looping operation so that you can use the machine code to program how the CPU runs by giving the instruction on ROM.